Welcome to the deep dive. Today, we're going to unpack some insights from a scientific report looking at refining ETL prioritization. Basically, how to handle huge, messy, interconnected data sets efficiently.
Exactly. The mission really is figuring out how to optimize getting data ingestion for the best possible efficiency and, crucially, data integrity. It's about making that whole process smart, not just shoveling data around.
Okay, so let's start there. With these massive linked data sets, what actually goes wrong if you don't prioritize intelligently? Like, why isn't just processing things one after another good enough?
Yeah, that's the core problem. If you just go sequentially, you hit massive bottlenecks. The issue is the dependencies data element A needs data element B to exist first. Without a plan, you get errors, data corruption. It's like trying to build a house but putting the roof on before the walls.
Right, total chaos.
You end up with serious integrity issues because you haven't loaded the foundational stuff first.
So the report mentions that, the first ideas for categorizing the data were a bit too simple. What was wrong with just using something like inheritance?
Well, inheritance seemed logical at first to find those base type entities, the really foundational independent data points. But when you get down to the nitty gritty of ETL in a relational database, it just wasn't precise enough.
Not granular enough.
Exactly. They needed something much more sophisticated to truly define what independent means in this context.
Okay, so here's where it gets really interesting, right? The core solution they landed on, this CsvStrategyCategorizer service. What makes its approach so much better?
The breakthrough is how it looks at the actual structure of the data relationships. It uses JPA relationship annotations, things like at many tune, at one commony.
Ah, okay. Structural analysis.
Right. It classifies entities as either base type or regular. And the clever bit is the definition of base type.
Right.
It's an entity that does not have a many tune or a one tune relationship, pointing to another core entity within their main model, the brains graph model.
So it doesn't depend on another core thing being loaded first.
Precisely. But having other things depend on it, like through an at-one-tomity relationship, that's fine. That means it's truly independent, a foundational piece.
And you mentioned the brains graph model. That sounds important for making this precise. How does that fit in?
It's absolutely key. Think of the brains graph model as the definitive map of all the important data entities in their domain. Its vertex set lists exactly which entities are core.
Okay.
This lets the categorizer ignore, internal database stuff like tables used just for normalization and focus only on the critical dependencies needed for the right loading order. They call it topological ordering.
Topological ordering. So getting the sequence, absolutely right.
Yes. It ensures you load the truly independent lookup tables first, preventing those horrible circular dependency errors where A needs B, but B also needs A.
Got it. So we have the smart categorization telling us the loading order. How does the system actually do the loading? The report talks about a generic persistence model.
Ah, yeah, that's another really elegant piece. Instead of having separate ways to save every different type of data, they centralized it. There's a single brains-based entity repository and a single brains persistence service.
One service to handle everything.
Basically, yes. It's a unified, generic approach, handles all entity types. This massively cuts down on repetitive boilerplate code, the same saving logic written over and over again.
It makes sense. Much cleaner.
And it streamlines the whole ETL execution. Makes life way easier for the developers.
Okay, so smart ordering, generic saving, and then there's this dual primary key strategy. How does that interact with the prioritized loading?
This is where it all connects beautifully. See, data comes in from the outside world with its own identifier, an external brains key. Think of it like a music brains GID, a unique natural key.
Right, the source system's ID.
Exactly. That key is used for identity figuring out if we need to update an existing record or insert a new one. But internally, for performance, the database uses a standard long ID, a surrogate key, for all of the connections, the foreign key relationships.
Okay, so two keys for everything.
Yep. And the prioritized loading makes it work. Because parents are loaded first, when a child entity comes along, the system can use the parent's external brains key to quickly look up its internal long ID.
Ah, so it finds the internal parent ID needed to link the child correctly.
Precisely. It bridges the external identity to the internal structure just before saving the child. Really slick.
It definitely sounds like a solid system. But how do they know it works? What about validation? These things can get complex.
Good question. Validation is crucial. They use something called CsvStrategyCategorizer test. And the key thing is, It's a pure Spring Boot test,
Meaning?
meaning no mocks, no simulations. It uses the actual application configuration, the real domain models. It's testing the real thing end-to-end in that component's context.
That sounds robust.
It is. And they even mention having a test that basically just prints out the categorized strategies, a sort of visual inspection step, which I think is great, a human sanity check to make sure the logic looks right.
Okay, so wrapping this up. What's the big takeaway here? It seems like this refined CSV strategy categorizer, combined with the generic persistence and the dual keys, it creates a really smart framework.
Absolutely. It's a cohesive, intelligent, and very efficient way to handle complex interdependent data ingestion. It tackles the dependency problem head on.
A powerful solution.
Which leads to maybe a final thought for you listening. How much deeper could you go in understanding the structure and the relationships within your own data? Beyond just, the values in the fields? Could uncovering those subtle underlying connections unlock completely new levels of efficiency and integrity in the systems you're working with?